Today, our first speaker is Tal Friedman. Those of you who came to NXTBLD last year would have seen some very impressive facade designs by Tal. Today, he's going to be talking about parametric architecture and digital construction. And he's going to be asking the questions about how AI algorithms, robotics, and new technologies can bring down the cost of advanced manufacturing and create iconic architectural buildings.
Hello, everyone. Thank you very much for coming. I really appreciate it, especially in these times. I think that these challenges are extreme, also on a personal and on an industry level. And I do want to give a virtual round of applause for the NXTBLD team, for Martin, Greg, and everyone for making this happen once again. Last year, I was in London for the physical event. I had the privilege of meeting a lot of you guys, and I had the privilege to present my work and get feedback, and I still keep in touch with many people that I've met there. And as I say, the show must go on, and I'm so glad to see that this is happening. And I think this is a great contribution to the building industry as a whole. And of course, with the new challenges of COVID, I'm glad to see the adaptation and really happy to be a part of it. So I hope you enjoy the talk, and I'm really looking forward to hearing your feedback. Thank you very much. So as the title suggests, my name is Tal Friedman. I'm an architect and have a master's in computational design for construction. My talk is going to be about from digital design to physical construction, how to bridge the gap between the two and move to an age of construction 4.0, combining smart algorithms with robotic automation to create a new architectural reality. You can see an example of my work right here. The office deals mainly with architecture, consulting, product design, parametrics, and also functions as a startup developing design to fabrication, hardware and software, combining the two in things that you will see as we go along. I think the age we're living in right now is an age of technology. It's a wonderful age that's really rapidly changing how we perceive architecture. We all know these great buildings that you see in front of you. A real new generation has emerged and, shifted our perception to what architecture can be. But when we look at the architecture world, we have to ask, how does that actually affect our mainstream world? Has that created the effect we want? And as people coming from the AEC industry, developers, how are we contributing to our built environment to have more of those and less cubes and blocks and these things that we're seeing all around us? So if we just take one look at a different industry, the automotive industry, we see a huge gap, in the last 100 years. We see a car that has become a complete technology wonder, becoming something which is faster, cheaper, and safer in just 100 years. And we should say that it's also about 10 times cheaper relative to what it was back then, which is quite amazing. But if we look at another field called the construction sector, we see something completely different. If you look at construction 100 years ago or even more, you'll see a much more desirable living environment, and you'll see that the new construction that we have for the mainstream is much higher in CO2 emission, less energy efficient, has much lower design and wellness for its inhabitants, and has much relative high costs. So, if we were actually an alien looking at the world and we saw this picture, we may think that the left one is the later version of the right one, but this is not the case. We are still living in the age of just hire a architect, where we are living in a low-tech world comprised by a lot of repetitive elements, and we are the advanced tooling. And we are still living here in the world of construction components, where we can design a lot of BIM tools, but in the end, we have to ask the question of what are we actually building the product with? Do we have any control over the means of manufacturing? And how can we actually affect those means to create better buildings? That's at least the questions that I deal with on an everyday basis, and I'll show you on which levels. So of course, we want to lead the material 4.0 revolution because we're talking in the end about manufacturing, and we want to reach things like this on a much larger scale. Now, if we look at Zaha Hadid projects, which is always the best example for extravagant architecture that twists our imagination, we will always see those mass customized elements that are so hard to achieve, and for that reason, I would say are a very one-off possibility. So again, a great project, but if we look under the hood, we're going to see things that unfortunately for our everyday environment will not be so feasible. So mainstream construction, back to reality, 99% of the buildings look exactly the same, they're built the same, and unfortunately they create they create environments that we simply don't like, if to be quite honest. We all want to go to Paris, we want to go to those nice areas. Buildings are a main attractor point, and we see this all over the world. We go on vacations to see architectural wonders. The rule of society is that people are by beautiful buildings, and inspired people do great things. That's just how it is, and we have to help that happen. So what do we want? What do we actually want from all of this? I call it democratizing architecture. We have to satisfy these 5 different criteria. Architects want to design better buildings. Contractors want to reduce time and errors, and of course cost. Governments would like to reduce CO2 emissions and energy consumption. Real estate developers want to increase their profits, and us people just want to live in a well-being environment and be inspired. So, these are completely conflicting in today's world, and as long as we can't solve the equation, we're in deep trouble, because, the architect, when he designs something beautiful, that's going to, create a conflict with the contractor because he raises the costs. That will create a conflict with the real estate developer. And vice versa. You can see here that everything goes on the expense of the other, and we have to find those solutions. Of course, we have to deal with manual labor, insufficient systems, and low-tech methods as a part of that, but we can do it with the right approach. So the ping pong effect is something that we have to take into account. That's something that I think is our job to solve. How do we take all of these different roles and combine them together in one adaptable system? So as I mentioned, what we try to do at Voltstruct is take those systems and try to create the movement within the basic DNA to say, let's start off with a certain geometry. What happens when we change the geometry? How can we build something which is completely adaptable? But of course, living in the everyday world, we would mostly be confronted with projects like this. And this is an input model that we are working on, which is a basic BIM model. And in a one-click solution, as we like to call it, we would like to move to things that look like this, that are based on the same type of input and are based on things like budget, manufacturing time, details. So these are extremely important to take into account whenever you're designing something with a limited budget. I'd like to take you on a little journey to how I design, basically. And one of the things I like to do is design for industrial design. This one model that you're seeing here is a chair that is actually created mostly by an algorithm. If I should go to the next slide, you can see that the input here is extremely simple. You can see the process, and then you can see the output. Now, this is just to show that when we know exactly what we want to do and when the algorithms are adapted to our design, all we have to do is provide a very, very simple input, which can also be optimized, and we can have great things done. And this is, of course, just a small scale example, and we try to take that one step further to more advanced and complex things like architecture. I'm going to show you a little demonstration movie right now so you can see some of the details that are deriving from that. So going back to the architectural scale, I'm going to display a couple of projects that we work on to display how we treat material, how to take simple details and create diversity within. The idea of wood joints is an idea that's been around for thousands of years, and it's one of the basic building blocks of the building world, I'd say. And we try to take that and ask, well, how do we take that and create an adaptable system, a diversity within a very, very modular design? And of course, always being inspired by nature, I took this cow skeleton scheme and tried to create that instead of creating bones, taking wood logs and then cutting them accordingly. And you can see some of these shop drawings here that lead to a kind of curvy look of the building. Another interesting topic is modular systems. It's now called prefab, modular construction. There are many, many names for this. And basically, the main reason that it has so many names is that so many people are trying to solve how do we create industrialization for construction, and how do we contribute to the actual building by doing so. You know, the communists have tried to create those modular construction blocks where everything is uniform, and we know what happened. So I think one of the main questions we are still left with is how to benefit the design and how to create a scalability that would also be able to adapt to the human scale. So we're always talking about scalability of how to enlarge something, but here we actually have to find a way to make it a bit smaller and more kind of in touch with our human side. So here's a project that we're working on, which tries to take the idea of modular elements that are nested in different ways and have a diversity within the way that they are put on top of one another. So they are still made in a prefab way, just assembled differently and designed differently. And you can see here a couple of examples what this may look like, and you can see on an architectural scale how every little movement creates a space here. And in the end, you know, these little spaces create this thing called architecture. It's all about the little spaces. It's all about the interaction between spaces, people. And I think the parametric era leads, you know, has a great thing to say about how spaces are created. I should say that most of the things here were not even thought of before, right? It's when you start to play and move around with the adaptable systems that you start to see these spaces creating. And you can see here those green elements rising. And well, I just really enjoyed this specific project because it surprised me in so many ways. The next topic I'd like to touch upon is the idea of shading, creating energy efficiency for glass towers, which is so needed these days because we're talking about the need to reduce also the reflection coming out of the building and, of course, the sun going in. So this is an adaptable system that we are designing that can fit onto various projects and kind of be in touch with a parametric design environment. You can see here basically how we take a very standard cube and by applying the parametric logic create something which blends very nicely with the shadow of the city, and I think creates an added value from just a standard block, and of course has great energy efficiency attributes. Some of these things we do also have to do with the design of skins. So if you want to reduce the amount of glass in the building, one way is to create shading, the other is to simply create a skin over that. But there's always the challenge of creating skins on a large scale. And one of the reasons that we need this parametric era is to solve these problems. So here's one of the examples. Biomimicry is one of my favorite topics. This is a special project for me because I did not have any idea of what I wanted to design. I just knew that I really liked these ideas of the eyeball kind of the fly. And looking much deeper into it, I saw the potential of creating a diversity in geometry using just one mold, because you can see that these all could be estimated to a sphere. And I thought, how can we take that one step higher and create a free form that we can control but still use a 1 mold solution that is cut differently in a different silhouette every time, as you can see here. This, of course, leads to many, many interesting new designs. I should say that the final output does not resemble in any way my input for that. It was really, really interesting to see what forms, of course, everything is adaptable by parametric sliders, so you can decide what the size of those molds is going to be or how many different types there are going to be. Yeah, so one of the most important things here is, of course, those profiles, and you can see in this close-up that the profiles are also following a very basic radius that makes it much simpler for fabrication. So I think this is a project that demonstrates, at least for me, how we can, enter a project without knowing too much about it by seeing a type of logic that makes sense to us and then applying that in different fields. This one is a project we did for that deals with the idea of curved surfaces deriving from ruled surfaces and how to create concrete molds in a more efficient way without needing to create those kind of CNC milled double curvature forms. So here, this could all be created from straight lines. And I think this is a good example how we can reduce the cost and yet still produce double curvature in a sense. The next project I'd like to talk about is the fold struct initiation, which was the actual folding of an object and how to create architecture from folded elements. I'd like to quote Albert Einstein in saying that things should be made as simple as possible, but not simpler than that. And that quote led me to the work on the actual fold struct method, which talks about the simplest and purest form of a structure as being a folded piece of sheet material or paper in this case. And so we know that when we fold a piece of paper, we get a stiffened piece, but we also know that there's not too much control over that. And so what happens when we add a little bit of logic into that folding process? Suddenly we get the art of origami and a limitless world opens up. So origami, for me at least, is a way of thought. And I've begun this journey with a lot of thought experiments, folding experiments. And the most ideal situation for me was to just create something out of one sheet of material and say that anything that we can fold from paper, we can probably fold from metal or plastic or any smart material we can find. But then you also learn that there are material restraints and we have to kind of work with what we have. So if we look at the world of sheet materials, there are so many limitations there, but on the other hand, so many opportunities which we try to take advantage of. So here's the initial design here that was the beginning of the origami pavilion project that I'll display now. And what we did here, that was actually a project that I did as a student in Detmold University in Germany, together with the help of a Luca-bond. It was first to create this kind of approach, systematic approach. And you can see here that by studying the geometry and the math, that really opens up a whole new world of what is available and how to go from 2D to 3D. This is, of course, a much later example of where we are today in taking these technologies and creating double curvature from folded elements. And here we're already implementing, all the knowledge and the algorithms that were studied initially and creating things that take us to a completely new level that, for me at least, starting out, were not in the plan and unimagined. So if we look at this project specifically, we can see how we went from design to reality, working in a 0.2 millimeter precision. And if you look at the way we build it, I think it was, for me at least, extremely exciting because we used a material that had no substructure at all. It was almost as if folding a piece of paper. And the results were quite structural, as you can see here in the slides. This is another example of a bench that I created that was created from just one piece of material. So no welding, no post-processing, everything is cut and folded. And this was actually an interesting project because it shows the structural abilities and the ability to create actual objects by folding. So the idea is to go from laconic to iconic, and how can we take that technology and inform existing buildings and create better architecture with this? And that's what it's all about. We have questions like the finite element analysis of how to analyze a fold, which is a part of the work. You can see here in the fabrication process how to evaluate your design always has to do with building mock-ups, touching the material, you know, just feeling it with your hands, I think, is kind of the missing link between the AEC industry dealing with digital design and actual construction. So for me, it's always interesting to touch the material and to feel it with your hands before even going to through that digital process. You can see here all the fabrication details, and yeah, that that project is 4 millimeter thick, having no substructure at all, and has stood weather conditions in very high degrees. This is another example of where this can be taken on a more free-form approach, and I would now like to show you a couple of movies describing the fold-struct process and some examples. So finally, I'd like to show you a new project that we're working on right now, which is a wood pavilion that is based on parametric design and form finding. It's interesting because the attempt is to use a very simple mechanism of wood logs in order to create a freeform canopy. So this is actually the first time that I'm presenting it, and I look forward to hearing your feedback after the session. Thank you so much. It was a pleasure, as always, to present at NXTBLD. Thank you.
Our next presenter is Chris Rufo, the worldwide segment lead for AEC and product development in the Lenovo Workstations Group. Chris joins us to delve into some of the top trends and technologies that are changing the way we work within the AEC industry today and into the future.
Welcome to NXTBLD 2020. I'm Chris Rufo. I'm the segment lead for Architecture and Engineering in Lenovo Workstation Group. I think what I appreciate most about NXTBLD and what Martin and the team at AEC Magazine is doing is they've created a really robust dialogue about technology and how it links to practice for what's next with BIM. So we're going to spend a little bit of time talking about some of the things that we're tracking in terms of trends, and they track very closely to what's being presented at NXTBLD. Scott's going to join and talk a little bit about what we're hearing from users like you. And then Mike's going to drive it home and talk about how we're taking all of this feedback, what we're tracking, what we're learning, and putting it into our portfolio solutions. So I think one of the biggest trends we've all been tracking is mobility is the new norm. I think the work from home mandate has impacted all of us across the entire practice. And we're seeing an increased demand for mobile workstations. People want thinner, faster, lighter mobile workstations. They want more powerful GPU capabilities. And we're seeing a number of users are really exploring what it means to tie their mobile workstation to either a rack workstation or a desktop workstation back in the office, because IP and security is extremely important. You know, we're looking at a number of scenarios between one-to-one and one-to-many connections between a mobile workstation and a server back in the office. I think the next trend, and in fact, it's really an interesting conversation this year, is around the convergence of manufacturing and building, how those two are connecting. And there are a number of great presentations, from Molly's session to Bruce's to Tal's, which is running in our segment here. I think 2 years ago, Hedwig Heisman from Deuce and Actual came out, and they presented how that they are building products at an industrial scale, fabricating them in a sustainable and circular manner. And we see this as being probably the most interesting trend in the industry moving forward. Virtual communication is also extremely important. This covers everything from visualization to rendering in real time. Let's talk about a couple of examples. What we see here, we've had an ongoing partnership with Vario, and when you see this technology demoed live, it's fascinating, because what they're able to do is combine a virtual reality experience with a mixed reality experience. So what you're seeing here in the video is a user with the headset on. You can actually see through, because you can see the camera, see your hand. The space is real. The car is fabricated. And both are presented in such a lifelike manner that it's really easy to make very, very informed design decisions through this virtual environment in a manner that simply wasn't possible even 2 years ago. Visualization is in real time. Last year, Carlos from Neoscape presented a fabulous presentation. He showed us the latest of what's possible with NVIDIA RTX graphics in one of our mobile workstations and a desktop workstation. So what you're seeing here is actually being rendered out in real time in the Unreal Engine. And I think what this means for all of us is that real design decisions can be made in the boardroom in a presentation with a client, rather than having to round trip back to the office to the render farm to get a decision made. And I think we'll see in other sessions, like Ken Pimentel's session from Epic Games, that it's not just about pretty pictures and real-time rendering. Visualization is becoming a critical part of the design process itself. So last but not least is a trend that's tying all of these things together. If you remember 2 years ago, we had Gijs van der Velden from MX3D come out and present about the world's first 3D printed bridge. The bridge is finished now. It's really exciting. I spoke to Gijs last week. The bridge is done. It's ready to be installed, hopefully later than in the month. They've got all their planning permissions, all checks are go. So fingers crossed the bridge will be installed later in the month. But the exciting part of the story is the next chapter is that the bridge has been outfitted with a sensor network, almost like an IoT nervous system. So cameras, displacement sensors, accelerometers, weather sensors. So we'll be able to track the bridge in real time as almost like a living organism, and we'll be able to understand how the bridge is performing in real time versus its design spec. It'll understand, the environment in which it's in, and all this data is going to be captured through the sensors and be able to analyze through machine learning algorithms and various AI implementations. So it's going to be an exciting couple of years as we get to learn from this data that's being captured. So these are some of the high level trends that we've been tracking. It's important to us because it really informs the portfolio that we're building. And I'm going to pass it over to Scott here, who's going to talk to you a little bit about some of the data that we've been collecting and what you've been saying as users.
Thanks, Chris. I appreciate being here. It is just amazing year after year to see how this industry continues to push the technology and improve the way that we all work, whether it be our partners or our end users. So I'm glad to be a part of it. Of course, would much rather be a part of it in person, but we all understand the challenges there, and I applaud the team that's put together a really amazing digital session. So I'm excited about this, as well as our Q&A discussions later. As Chris mentioned, I'm Scott Rupert. My role within Lenovo is the Workstation Portfolio Planner. So that means I get to work on what's coming next in our workstation portfolio. Product focused, but really the core of my job is understanding these trends that Chris just went through, where those intersect what our partners are doing, CPU and GPU and these advances in the core technology, and how we integrate that into the workstations that you all use. And so, of course, more important than any of that would be the feedback that we get from the actual end users, from folks like yourselves. How are you using these products? How do you need these tools to get your job done? And how can we make them better? I would say, looking back over the past several years, there's lots of examples of where we have brought products to life based on user feedback. One example you're probably familiar with, the P52 was the first mobile workstation to be VR ready, to support a VR experience from a mobile product. And then its follow-on, the P53 was the first to bring Quadro 5000 class of graphics into that 15-inch mobile workstation. Again, increased performance and increasing mobility. So I know that's a trend we've been talking about for quite a while, and we keep trying to push that forward. The ThinkPad P1, another great example of that. While we weren't necessarily first to market with that product, we went through several iterations based on user feedback and based on improving the reliability of it and the robustness, the mil-spec testing, all those things that we love to talk about. Again, all those things find their root in end user feedback, whether it be the smallest workstation, the tiny, to bring a Threadripper Pro to a workstation, right? All of that started with conversations with end users. Now, I will say, of course, this year has made that more challenging. And I do hope that we can have some of these conversations in person. I look forward to the Q&A session. But we are supplementing that as best we can through, smaller virtual conversations, sessions like this, as well as surveys online and otherwise gathering data. And then in this year, with the challenges of the pandemic and this quick pivot to working from home and a little bit of unknown about what going back to the office might or might not look like in the future, we have added another layer of complexity to it, if you will. And so we've tried to capture data about that as well. And we're using some of that information to inform the product portfolio. So all of the trends that Chris was talking about, plus this, maybe shift in how we're working today, this year, next year. And then how does that also inform the solutions that we're focusing on that Mike's going to talk about here in a couple of minutes. So I have, several surveys, quite a bit of data. I've sort of netted it out, a few graphs here to share. A couple of the areas I don't think you'll be surprised by. Connectivity, of course, was one of the biggest ones. Everybody got home. There's plenty of stories about people that took desktop workstations home and didn't realize they couldn't connect to the internet. There's plenty of stories about folks that took 100 meters of Ethernet cable home and ran it, from their router down to their kitchen table, and fun things like that. But to enhance the data and to really get a feel for what was going on, we added one open-ended question in there that just said, what has been your biggest challenge this year? What has surprised you, or maybe what's kept you up at night? And I will say this has gone to a variety of different industries, different workstation end users, but a lot of these themes are the same, and I think they'll resonate, right? Is the quality of my work being displayed remotely when I'm doing these kind of digital presentations? Are my teams as productive as they should be? Very specific things like full resolution desktop. Security, of course, is top of mind. VPNs, and all of these things. Mapping that to some of these other trends like moving to mobile, right? Did my team have mobile workstations? Could I send them home? Sometimes the workstation can't leave the building, and other times the hardware maybe can, but the data set, the IP, the project proper, the content cannot. So do we have the right remote solutions in place, right? And so those are all areas that we want to help with. Those are all areas that we want to gather data on and continue the conversation. And so with that as a backdrop, before I hand it off to Mike, I will say, this is near and dear to my heart, of course. So I love to continue the conversation. I'd love to gather some more data. We'll try all the different forms of technology that we have. I think an easy question for the audience, you can stew on this, and we can talk about it in the Q&A. Is when have you returned to the office? Are you returning to the office soon? Are you never returning to the office? Is the productivity such that it makes more sense to stay home? I have talked to folks that fit in all those categories. I can tell you us at Lenovo here in our office, we're not going back till at least January. And so we're continuing to adapt and rethinking what the rest of this year looks like and heading into next spring. And then I would like to make the survey available to all of you. I would love to hear your voice in this. Thank you for joining us. I'm going to hand it off to my friend Mike Leach, our solutions manager, and we can pivot with that as a backdrop to, again, back to more about how you work and how are you using these tools that we create to be the most productive. So thank you, Mike.
Thank you, Scott. Appreciate your time. And again, welcome everybody to NXTBLD 2020. So different time, different format, but I welcome everybody. Hope you found the event useful so far. Some really great speakers this year. So looking forward to seeing more of the event. So as I've discussed, I've spoken before at NXTBLD. My role within the Lenovo is a solution portfolio manager. So it's my role to look at the convergence of technology that the likes of Chris can see within the AEC and the architecture engineering world, and see how that converges with some of the key technology trends that we see, to ultimately help build out not just physical products but total solutions of how these can then help you be more productive no matter what the old or new normal may be. So I just wanted to share a couple of slides just to kind of see, well, this is how, this is what's ultimately changing in the world today. We've taken initially, this workforce agility. We're seeing now, a massive 62% of employees, they still remain in sort of a work from home environment. People pivoted very quickly to ultimately what was a new norm, and that will ultimately sort of map out and start to become this new trend moving forward. But things like security, there's been a 300% increase in cybersecurity since the pandemic at the start of the year, and ultimately now industries have to act a little bit differently. They need this workforce mobility, this digital transformation. They've almost needed to spin up their own disaster recovery plan when there ultimately may have not been a plan there in the first place. So taking our traditional products, we've had a very good portfolio of ThinkStation and ThinkPad mobile workstations. Pairing those with some of our ThinkVision monitors and some of the standard Think accessories, everything from docking stations, presenting tools, mice, keyboards. And we've been able to sort of equip that new home home worker with everything they need, but still allowing IT management to have full control over that device. So that might be remote security, that might be remote management, physical updates, our ThinkShield security wrapper that connects all of those, dovetailing very well into the ThinkPad P series with remote diagnostics, workstation diagnostics, and the Lenovo Performance Tuner. We've made sure that no matter what the firm or practice may be running, any application, any workflow, they've got the ability now to connect straight into that at maximum speed. So in the convergence as we see from a manufacturing to a building environment, those applications which now are driven by high clock speeds, high core counts, or high GPU, there's now very limited drop in productivity as we've seen more and more people start to utilize these. We've then seen, the transition then to kind of that remote workstation. So equipping every home worker with a powerful high-performance workstation like our ThinkPad P53 or the new ThinkPad P15, might not be feasible for everybody. So we've invested heavily in a complete remote workstation solution, an end-to-end platform that takes those desktop workstations or even our new rack-mounted workstation that can still be physically located in the office, and then provide that with a true 256-bit encrypted platform where the user can access that workstation from any location over Wi-Fi, 4G, 5G, internet, from anywhere else in the world. So the problems that Scott mentioned around security, data set sizes, maybe IP not being able to go home, or you're now obviously working with globally dispersed workforces of people maybe head home or head to work from different locations. You now centralize that performance, you centralize that workstation estate within the office or within the data center. And your users can now have complete access to that in a very fast environment, which has typically before never been possible. So when you access remote, people have used things like RDP from Microsoft, you find that the workstation itself is quite clunky. There's lots of latency, there's lots of reduced performance. And as we see now, using the technology we have, we're working with Macdyne Corporation on their TGX remote workstation software. This delivers an NVIDIA GPU accelerated experience end to end. So regardless of what client device you have, bring or choose your own device strategy for your users. You can use your NVIDIA powered workstations that are located back in the office and connect to those in an as local like experience. So when I say as local, what I mean is the user doesn't appreciate that they're using a remote workstation. So the performance is just like they're sat in front of that platform. They log in like they would do from their normal laptop or desktop, but they're actually connecting through to high performance, powerful hardware located in a different location. The mouse to keyboard interactions are seamless. You can run 3D connection motion controllers and space mice. You can run touchscreen navigation. It's a very, very easy way to power that remote hardware. And then you can share and split that resource out to collaborate with other users. So in the old norm, where you maybe go into a centralized meeting room and collaborate over a single project, either projected BIM model onto a large LCD display, you can now join a Teams call, but in a separate window, you can each log into that workstation and take control of that 3D architecture software. You can mark up and make real-time changes, maintaining maximum performance, maximum efficiency, throughout that entire project. So the remote workstation in collaboration with our workforce agility solutions really now give you that the ability to turn on a knife edge. So no matter what the future or new norm may be for your architectural practice, you have that solution there to back that up. And one of the the additions to that will be sort of immersive solutions. So back to scalability. You want immersive visualization, VR, 3D rendering, real-time graphics like we've seen from NVIDIA RTX. It's start to having that collaboration experience in not just the physical world, but in the virtual environment as well. So working closely with Vario, we do have now the world's only true 2020 eye tracking, human eye resolution, professional VR and XR solution. So we've taken our ThinkStation or our ThinkPad mobile workstations, and we've supplied those then with the Vario, the VR2 Pro or their new XR1 augmented reality display. To give you now that ability to have a much quicker project time to market and collaboration experience. So you don't have to stop production workflow to sort of move in and out of 2D, 3D or VR environments. You can now put the headset on and you can immersively then track and obviously start to work in a very much collaborative environment, but it's at human eye resolution. It's at the much higher field of view, and the much higher pixel quality itself. So you can do things like read text and see finite sort of product details, stitching within fabrics, photorealism, and that sort of thing. So it's moving the sort of the commercialized consumer VR technology into the true enterprise space. And we've obviously got plug and play solutions on the desktop and mobile workstation side to help fully support that. And we're looking forward, most importantly, to see where this can go and how more of a remote collaboration experience, be it in virtual or mixed reality, workforce agility, and remote workstations, can now kind of bring that new hardware pipeline in that can be the new norm and the foundation for all architectural practices as we move forward this year. So I want to say thank you everybody for their time. We've got some really great questions and a good Q&A, live Q&A session coming. So really welcome the feedback and to interact with you on here. So on behalf of myself and Scott and Chris Rufo, thank you for watching.
Our final talk today comes from Michael Katz of AMD. Those of you who are into your hardware know about Threadripper Pro and all the latest hardware trends coming out of AMD to compete with Intel processors. We're going to hear about what kind of benefits Threadripper can provide high-end customers and high-end users of simulation, rendering, and AI.
Hi, welcome, and thank you for joining our session. I'm Michael Katz, and I'm joined by my friend and colleague, Rob Jameson. In our respective roles here at AMD, we work with software companies to ensure that key applications perform exquisitely with AMD silicon. We have some very exciting developments to share with you today, so let's get started. As a publicly traded company, we are obliged to include this legal disclaimer about forward-looking statements. Apologies for the eye chart, but this is a small price to pay for being on the leading edge of technology. So just a quick reminder about who AMD is. We make powerful computing and graphics chips that drive the most demanding experiences in industry, high-performance computing, data center, gaming, and more. And AMD has been a disruptive innovator for decades, but the pace of innovation has accelerated dramatically over the past 18 months with the introduction of 7-nanometer manufacturing, Infinity Fabric, and the chiplet design paradigm in the latest iteration of the Zen architecture, resulting in first to market in PCI Gen 4, first 64-core desktop processor, driving 8-core 16-thread notebooks into the mainstream, and most recently, the Threadripper Pro, which we'll hear more about here shortly. Releasing these technologies has solidified AMD's position as the innovation leader in compute. So architects spend every day designing the office of the future. I feel like I'm in it here, but maybe open floor plans like this may be falling out of vogue, and we'll have to rapidly change up our game in design. Innovation in technology has proven to be a key enabler in the design and the ability to nimbly move around as the market demands. And in fact, 70% of surveyed architects and visualizers noted that increased reliance on technology was the #1 change in their industry. This surprised me because it's twice as many people who said that sustainable designs were the top impact of change in their industry. So furthermore, high resolution graphics and frame rates of professional VR has driven compute demand. And even more so than graphics, there's been an explosion in data and processing, BIM data, smart building sensor data, structural analysis calculations, airflow and filtration simulations are especially top of mind these days. The list goes on and on. To handle these massive explosions of graphics and data, we're pleased to introduce you to the Lenovo ThinkStation P620, the world's first professional workstation based on the AMD Threadripper Pro processor and platform. This hardware is truly groundbreaking and by every measure offers the ultimate in flexibility, performance, and longevity. So let's take a closer look at what's inside. What I mean by longevity is it's the most future-proof workstation on the market with support for PCI Gen 4. This enables twice the transfer speed between the CPU and peripherals over legacy PCI Gen 3 platforms. This means support for the fastest Gen 4 NVMe storage drives, especially impactful when loading and saving large models. 8 memory channels supporting up to 1 terabyte of fast RAM. built-in 10 gig Ethernet for firms using network attached storage. And with 128 lanes of PCI Gen 4, the P620 supports up to 4 single width GPUs or 2 top of the line double width GPUs and a 1000 watt power supply that's big enough to drive them. In the past, organizations have had to select different workstation form factors and processor families based on individual workloads. The P620 changes all of that. Now, a single mid-size workstation chassis offers a range of processor options to meet the needs of every user in the organization, from the 12-core 3945WX all the way to the industry's fastest workstation processor, the 64-core 3995WX. With these options, the ThinkStation P620 enables IT organizations to standardize without compromise and realize the total cost of ownership benefits that come with having a unified platform under every desk. One more thing about 64-core 3995WX. We've noticed a trend to use expensive cloud resources for render and simulation tasks. Now that high core count workstations are accessible on the desktop, we expect more firms to bring these jobs back in-house and make better use of their capital expenditures. Being in the software ecosystem, Rob and I know quite well that the highest performance hardware is only as capable as the software that will run on it. So let's talk a little bit more about the software for the industry. So Lenovo has gotten off to a great start by certifying the P620 through the stringent certification programs for all the software companies shown here on the screen. You'll recognize especially the software companies in bold, but there are many other applications for which there are no formal certification programs. The P620 is eminently flexible there. It supports Windows 10 Pro, Ubuntu 20.04 LTS, and Red Hat Enterprise 8.2. So it's compatible with pretty much every software application that you'll need or use. Now, certification tells you that the software works, but not how fast the software runs. So we work closely at that next level with industry leaders, including here on the screen references to Epic and Chaos Group. Epic's Unreal Engine has become so popular for every aspect of visualization, and they tell us that in the past, they've had to make the trade-off between a high core count system or a high clock speed system. With Threadripper Pro, they no longer have to make that trade-off. And Chaos Group, makers of the very popular V-Ray renderer, they sum it up nicely when they say that the P620 is a render monster. And if you haven't heard of them yet, ACA is the largest BIM provider in Italy, and they're growing rapidly internationally as well. They've integrated AMD technologies into their rendering, which you can see in action on screen, and they love the raw power that Threadripper provides for both design and render tasks. So 64-core processors have only been available for a short time, and performance has proven to be great out of the box. However, there's more performance to be gained, and we work closely with software companies to take further advantage of the full power of these processors. For example, we have a strong relationship ongoing with Autodesk, and using techniques identified and recommended by AMD, the Arnold team was able to realize modest performance improvements on legacy processors and tremendous gains on the Threadripper Pro platform. But we've been at this for a while. We launched the first gen Threadripper in 2017. Early adopters were rewarded with great performance gains and enhanced productivity. But now we have nearly 4 years of engagements with software companies and end users, and the feedback has been incorporated, and it's brought us to the point of having a robust, mature solution to offer in partnership with Lenovo. So in summary, by every measure, we've delivered a powerhouse in conjunction with Lenovo. It has the newest and best technologies to give you that longevity, full spectrum performance, configurations for every desktop and every workflow, allowing IT organizations to standardize without compromise. And all of this comes with Lenovo's legendary ThinkStation quality and support. So now that you're aware of the full power of the ThinkStation P620, we can't wait to hear what you're able to accomplish with this amazing platform. Rob and I are both easy to find on LinkedIn or via email, and we hope that you will reach out and talk to us about how you can put this platform to work. We look forward to hearing from you.
Thanks, Mike, for doing all the talky bits. I think we're around as well for questions and answers after these sessions. So I'm going to put the kettle on, have a cup of tea, and waiting for lots of interesting questions. Thank you.
Sounds great. Thank you very much.
Welcome to day 4 of NXTBLD Virtual. The first day we had kind of presentations with really out there thinking. The second day we had some innovative software solutions. Monday we had digital fabrication, 3D printed concrete and CAM. And then today we've got a bit of a hardware special and some more digital fabrication with our friend Tal. So I'd definitely like to thank Tal Friedman for jumping in and giving us a presentation on where he's at with his innovative technologies. I've got Chris Rufo, Mike Leach, and Scott Rupert from Lenovo. There was a whole load of stuff in their presentation. It just was pretty much everything. It was really interesting. And Michael Katz and Rob Jameson, who wasn't on the presentation so much, have joined us from AMD, and these are the Threadripper superpower guys. So we've got quite a full house for today's session. And I think we'll kick off with Tal. Now, I'm more used to you using metal, so I was quite surprised when I saw your presentation. Wood, concrete, plastic, mold, injection, all types of stuff, and then you finish with wood struct, which was something a bit of a surprise. So can you tell us a little bit about how your journey with materials seems to have taken an all-encompassing view of the world?
Yeah, actually, yeah, that's true. I think the last year since the first NXTBLD, I've really taken a more experimental approach with other materials, and that has to do also with the feedback from different industries. You see that the industry is going to the age of mass customization and providing an adaptable system that can be used on multiple projects. Yesterday, you guys were talking about that in the concrete 3D printing, where the business model is to create an adaptable model and then have that printed. So basically, the experimental approach was just to try and go after the different types of building blocks of the industry and try to play around with that. The idea of building with wood started out with one project with these kind of ruled surfaces, and then I thought about taking the Jenga approach, where it's just one laid upon the other, mix that with a bit of voxels. So, that it's just the beginning, and the metal, I think we had a real opportunity to build it. But I think there are a lot of opportunities that lay ahead. So not limited to a single material in that sense.
So to go back to your original material, Kevin Quigley's asking, how do you actually fold the sheet? Is it using a robot or is there a standard method? Also, is the method only for single skin sheet materials, or could it be adapted for laminate sheet incorporating insulation?
Yeah, so that's a good question. I'll try to answer as much as I can without going into patents because a part of the IP talks about exactly how to fold. It's definitely not industry standard. So industry standard folding works on press brakes and creating pressure folds with tons of pressure. We have kind of a mix between a lot of different methods, and I should say the most the most novel part about it is actually the algorithms that allow us to create multiple folds all happening at the same time. And that's, again, a part of the IP. To answer the question about the types of material, we're definitely not limited. Anything that can bend or fold obviously can be folded, and definitely laminates and insulated materials are the next step when thinking about complete shell systems.
So finally, what sheet size can you handle?
Well, we are. So the question, I think, should be reversed. We can adapt to any sheet size, but sheet sizes are usually manufactured to specific sizes. So we usually have to downscale and not upscale, because the robot is not a single robot that's, it doesn't have a cage or anything like that. So we can kind of spread it out different locations. So I think we're not at the stage where we have to limit ourselves yet, because sheet metal is still very limited by its sizes. So we're definitely on the top end of where sheet sizes are today.
And a question from me, I mean, obviously you mentioned it in sort of passing that your facades look really expensive, but from talking to you in the past, you are working with manufacturers to take that sort of cost element out of it and make it more predictable. Can you tell us a little bit about what you're doing there?
Yeah, sure. So first of all, I'll have to take that as a compliment. Usually when they say something looks expensive, that's the goal is basically, the one of my old titles for the presentation was iconic architecture for the masses. And I think that iconic feel, right, or that designed look is something that today is considered a luxury just because of the way that we work, going from design to fabrication. And the approach that I try to take is going from fabrication to design. So I will not design something that I don't know exactly how to build it. And if you just give you a couple of examples, if you look at sheet sizes, and if you look at standard material, the moment that you step out of a certain, let's say, restraint, you're going to double your cost. The moment you go into double curvature, you're going to quadruple your cost. So the idea is to always limit your design and the design properties to something that's fabricatable. And that is something that we're working on in the software side together with the design side. So you will not slip out of your fabrication restraints. So to answer your question, it's not on the high scale of Zaha Hadid manufacturing. I would say it's on mid-high scale of standard architecture. We just use the material a little bit differently, but we do not go into 6-axis fabrication or molding. So there's no molding involved. I try to step away from technologies that I see as a barrier to hitting mainstream construction environments.
Good. Okay. I'm going to move on to Chris, Mike, and Scott. Question for Scott. Where are you investing the most R&D resources? Desktops, laptops, remote workstations? Also, to what extent has the ongoing situation with COVID influenced the direction of that R&D?
That's a great question, Martin. Thanks. I think it has definitely influenced us, and perhaps not in a way to change a direction, but to accelerate a direction. I think Chris opened up with that trend that we all have seen for some time of the move to mobility, and people wanting to be mobile and be, working from different places anyways. And I think this year just brought that, very, very quickly to a more important point. So I guess the answer to your first question would be a bit of a combination, but certainly more on the mobile side, mobile workstation, how to improve performance in a mobile workstation to catch up with what you've expected from your desktop workstation, if that's fair, right? So it's one thing to be mobile, but you need to have that performance on the go. And then I think to back that up would be the remote solutions as well. So we're also investing quite a bit in remote collaboration, remote solutions, not just remote access to the computer and the performance, but how do we work together remotely? That collaborative part of it.
I've got a question for Mike next, which is, will there be smaller Threadripper Pro workstations rather than a big tower?
Does that mean Martin or one of Kurt's?
Sorry, I've got two mics, sorry.
Yeah.
Okay, that's the first mic.
That's the Threadripper chip. Threadripper Pro chip is a set size. It comes, as we covered, in 12 core, 16 core, 32 and 64 core options. So how our partners at Lenovo implement that in form factors, chassis form factors, is entirely up to them.
It's a thermal issue, I guess, but Mr. Leach.
Yeah, so I think, so what Mike says, the architecture is a set size. I think what it delivers is fantastic, but we also have to bear in mind of what people wanted to do with it. If you have the most power, but it's shoehorned into the smallest chassis, then you do automatically reach scalability, flexibility, and thermal and power constraints. So you never want to sort of hold down the beast. So there's always that compromise of too small being, to the opposites. But yeah, we're happy with the form factor size we have as a mid-size, 35-litre chassis option. But yeah, we'll constantly monitor the market and see where that may take us.
Yeah. So carrying on with Mr. Leach. I'm going to call you Mr. Leach for now, just to save.
All right, thank you.
Calling in the incorrect. So can you stream VR from a remote workstation?
I think the quick and easy answer would be yes, but it's all defined on what that VR is. The solutions that we're working on, our rack-mounted workstation is capable of streaming VR over sort of Wi-Fi and 5G using the NVIDIA Cloud XR technology, but it's limited by what the headset is on the other end, and then maybe how large or complex that VR content is. So I think as long as customers are realistic on what's possible at the moment, and mainly driven by the headset manufacturers, then yes, it's possible. It's good for collaboration. I'm thinking, like, if you looked at probably the best way, like an automotive environment where you might want to have 4 or 5 people all huddling and around the same solution, and COVID's a good reason why that would have to be done remote. You could all have a headset and stream that from your local office, but be in your own cubicle or socially distanced at that time. But as we move into some of the higher end pieces, the partnership we have with Vario is a good example there. The fidelity of the headset, the amount of performance you need is still exceeding what's possibly to be streamed over Wi-Fi or 5G. So for the lower end mainstream, yes, but in the higher end, unfortunately, it still needs to be tethered like in a normal headset.
So even with 5G, it's a no-go?
I think for the very high end, I think the wider field of view, the higher pixel density, it's just the amount of pixels that you need to get from that. The host workstation still needs to have that GPU power. We're not far off, what's capable and then what can ultimately be compressed and sent down that line. But I think the defined use case needs to be more structured, more set in stone. When people think VR, it's the photorealistic. It's in the art of what's possible today. I'll mention Vario again, but their XR technology, their mixed reality. The quality is so high, you can't tell the difference between what's virtual and what's physical in that headset. So by having that type of experience, you're automatically then probably further away from where the remote streamed headset environment is. But if you can optimize the content to do so, and I know some of the Autodesk software suites, what's possible with VRED, it is capable, but you maybe just have to have that realistic view of, a couple of steps back from the ultimate fidelity experience, because that remote workstation still needs to send those pixels across that Wi-Fi network.
You never really know, because if you look at Tesla's truck, which is designed for low poly count anyway. If there's a design trend to having less polys in designs, then you might be able to get away with a kind of an 8-bit VR headset, which would obviously reduce how much.
We don't want modern architecture to start looking like a Super Mario Brothers game from the 80s. But I think it's always down. Even the remote workstation experience, everything is limited by your connection pipe to the cloud. And that might be everyone's great and they're on a Google Fiber network up and down, but sometimes they're not. Wi-Fi is always constrained. The more devices you have, security needs to be obviously put into place as well. And these all clip away at the available bandwidth. And you can only be as powerful as the pipe you have, to that remote experience, be it VR or a workstation. So I think, yeah, if there was a sliding bar on the quality count and you could move it lower to then have that, you know, that untethered experience, and I think people would take it, but it would kind of be only part of the workflow, because at some point you're going to want to dial back up the detail and then run off a tethered headset before you ultimately maybe sign off on that project.
Thanks for that. As we were talking about mobile workstations, which obviously Lenovo excel at, I'm going to ask Mr. Katz and Rob from AMD, when are we going to see a Ryzen or a Threadripper Pro in a mobile workstation?
I wish I could tell you. Very soon, very soon.
Okay.
But,
there's some NDA things we can't discuss.
Okay.
how about this quarter? Is that satisfactory?
I'll buy that. Yeah, that's great.
All right.
Okay. When does the AMD quarter run from? Just remind me.
We're on the calendar quarter.
Okay. Will there be a dual CPU Threadripper Pro workstation for more cores?
No, there will not. There will not. That's the domain. The dual socket is the domain of the EPYC server side of things. Now, we've seen some of the exotic system builders do some kind of different things with EPYC, but in a dual socket workstation. But in terms of what's certified, what we're targeting in terms of compatibility with the operating systems and everything else, Threadripper Pro is a single socket solution, and that is our highest end workstation that we promote as a professional workstation in the P620.
Okay.
Isn't 64 cores, 128 threads enough for you, Martin?
I think it's enough for me, but Greg, I think, wants more. Greg would like at least 128. Yeah, I'd hate to see the thermals on that, but yeah. So, as Rob, as you've come online, so in the software world, in the AEC software world, we have old bits of software, relatively new bits of software. It's been very hard for them to do proper multi-threading, to make use of the processors that we've used to, and so now we've got Threadripper and Threadripper Pro. So, how are you finding software developers taking on board what they could possibly do now if they were to develop on top of the architecture that is available already? We haven't had a great history of this. Are you getting any more kind of positive vibes from software developers that produce all the BIM tools?
In reality, these really big core count systems have only been out the last few years. You know what I mean? If you look about it, 3 or 4 years ago, we're happy with 4 cores. And now, you know, laptops have 8 cores, systems have 16, 32 cores. There is a software latency. It takes time for developers to start to realize that this is the new future. So there are a lot of software companies very interested in this. And even the graphics engines, the Vulkan and stuff, they make use of more cores already. It's part of their nature. And DX12 and Vulkan will make a difference, but also development needs to change. You know, we've been so used to having single threads, and there's some very famous large software applications which are, you know, will use 2 cores or 3 cores maximum. There is development. It's sort of fighting with the fact a lot of people want to use things remotely from the web. You know, people want which basically changes the development, because that's going back to more single thread. Between those two, there's a lot of new software coming out which is making use of more cores, and that's hopefully going to push some of the big boys to go that way as well. Well, I can't think of a good example. Go on.
If I could just chime in, though, that you know, so if the core design application is still single threaded, and yes, these are older, you know, decades old software legacies that are very difficult to move. We are having conversations with ISVs. We have developed some techniques to help ISVs leverage multi-core processors, even for low latency operations like geometry handling. But that to Rob's point, that's still very much in the early stages of those conversations. But what we have also seen is around the design applications, there are so many more new or high core count capable ancillary parts of the total workflow. So your generative design is a new one that's really come on strong. It takes very nice advantage of GPUs and multi-core CPUs. You've got your rendering, obviously, your visualization applications, and your simulation applications. These are all become more and more part of the design, rather than stages where things are kind of working through, where the analysis, the structural work, the generative design is part of the design. So we're seeing that trend of the main workstation has to be able to do all of these things well, not, there's a design workstation and then there's a rendering workstation. And it's having the facility to do all of those things well. I think is becoming more important as new software features come online with the various design packages.
Simulation.
Yeah, I think next year you'll start to see applications use more cores. I think there's some definitely large software applications out there that are moving using new APIs. So it's not that far away. I think next year you'll start to see several major software companies coming out with something which will show that more than 4 cores are interesting and will benefit from performance.
As
I wish I could say more, but there's NDAs.
Oh yeah, I'll take you out for a beer later. Well, post-COVID.
Virtual beer.
Talking about simulation and analysis, and going back to TAL. Obviously, you showed some interesting designs about in your facade development for solar shading. I'm just wondering, when you design in Rhino, do you use any analysis tools to help you design or help your algorithms design the shape of the facade?
Yeah, thanks for the question, Martin. Yeah, actually, I think for me at least, Rhino, as you know, is the main parametric tool. Rhino, Grasshopper, programming, things that we've actually done this year is starting to explore with other software as well. So multi-physics engines. I also have a little collaboration with Lenovo on that, and hopefully next time we can even talk about that. But actually using, a parametric system as a platform, and then bringing in, the output from another software, because you're very limited. There are tools for solar shading and analysis, but whenever you're kind of stuck in the environment of a plugin, you're very limited to what that plugin can do. And I think it's also interesting to be here on a platform with Lenovo and with the development of software and hardware, because the main idea is to go from your design, take it outwards to completely new worlds, and then, bring that into a quantitative score back into your design. So there are tools that we're working with to solve that. But for me, more importantly, is that the design, at least for me, is an open platform, and anyone can come onto those shaders and connect it to whatever input they want. That's at least the kind of methodology that I like to follow.
Yeah, I'm hearing a lot about openness ever since Thursday when we started this. I think it's been mentioned every day about the need for openness in our industry. I'm just wondering, you're predominantly based on Rhino, so I'm guessing as Rhino plugs into almost everything now, what kind of fabrication software are you having to work with when you go to fabricators?
Yeah, so basically fabricators like to work with SolidWorks, and if you're talking about 2D fabrication cutouts, let's say laser or CNC routing in the 2D environment, you'd actually be talking about DXF, very standardized files. So I think it's not really about the I would say the type of files you're using. It's more about the interoperability between the software. So if there's one thing that should be said in a conference about the AEC industry, is that it may be good for software vendors to make their closed systems and have everyone work in the cloud, but it should be said that those clouds are right now separate from one another. And if you were, not to go into specific names, right? But if you were to try to connect two clouds together, you'd make it rain, right? It doesn't work that well. And it's a little bit, we talked about this, and I'll just give that example. It's a little bit about like the toothbrush, the electronic toothbrush that they're trying to develop in order to sell more toothpaste, and not by thinking about the actual user. So everyone's thinking, how do we get them on a cloud? How do we subscribe them? How do we get them? The more I hear open platforms, the less I see it somehow. Yeah. I see the opposite. And I think Rhino Inside has raised the bar on that, but it's just one-sided, right? If you want to bring data back and then create a round loop, that's still quite a challenge, I think, at least for my end.
I kind of look at Rhino Inside as being like the Robin Hood of data interoperability. It just goes in and takes it. It doesn't really hang about and ask for permission. And maybe that's the kind of thing that was required for one company to do it. I think it's still early days for usages of Rhino Inside, but it's almost in everything. The Rob and I went to see ACA in Italy, and that's got Rhino Inside now. They did that in 12 weeks. We've got ArchiCAD, which is a full implementation of Rhino. BricsCAD has it in it. Rhino Inside also works inside Blender, and it works inside Unreal. So you're kind of seeing this proliferation of, and of course, Revit. So Rhino Inside is almost a platform within itself. So I'm really looking forward to hoping to see that, if that can nail some of that interoperability problem we've all got. My colleague Greg was asking, so the Woodstruck thing at the end, which was completely blew me away. Does that comprise a set of standard components? So you started off with the rule that it can only use standard components, or how do you go about doing Jenga CAD?
Yeah, Jenga CAD, exactly. So basically, I try to ask the question of, first of all, what is the building block and what is the DNA? And there I kind of chose a set of rules like orthogonal connections. They have to come one on top of the other. And they cannot, they can't leave those boundaries. So if you think of voxelizing something, you're always within the building restraints of the voxels. With the Woodstruck, I should say, it has a couple of different versions. There could be ruled surfaces, but then these ruled surfaces would need to have a projected wood log, right? The moment you start, it's about the different planes, right? If you have diversions in a certain plane, you'll have gaps. So you always have to find those restraints. And the modular, this kind of tower that I showed also has to do with modular construction from wood, which I saw as something that's really becoming quite common. And then I saw, okay, what can you do with it and what can't you do? And let's try working with what we have. I think there's so much to discover that's, undiscovered, that we should first stick to what we have. So I think that's the way, at least, to get things into a market and to have something feasible and not a one-off piece.
I don't know if you saw yesterday's talk with Bruce Spell from Facet, where we had in the Q&A, we were talking about CLT and how a lot of the wooden revolution that's going on in other places like North America, for instance, isn't really happening in the UK because the fear of it catching fire. So we kind of like ruled ourselves out of mass timber already because I think we fear it's going to explode. But we need some common sense rules here in the UK so that we can start taking advantage of the mass timber revolution. I'm sure that woodstruck will go down really well in a lot of countries. The UK you might have some issues, but still it was lovely. Enjoyed it. Going on to Mr. Leach. Sorry.
No, I said
okay,
the UK also.
I'll go back to Mr. Leach.
Also got the problems with it. Sorry, we have a small delay here.
Yeah, go.
Yeah, I said.
We'll come back. If I put a rack workstation in the office, wow, you got a huge delay. Hang on. If you put a rack workstation in the office, does it need its own server room? What about noise?
Yeah, so good questions. Yeah, so the rack workstation, it's a data center designed product. So it's our ThinkStation P920 rack is the first and it's the only product in our current portfolio that has been engineered for the data center. So essentially, it has very similar characteristics for thermals, power, and airflow and noise to that of a rack mounted server. So although it's not, in theory, you could operate it on a tabletop and plug it in and can give it network connectivity and access it remotely. It is essentially designed to be rack mounted, therefore in some sort of server cabinet. And then acoustics, it is not a desktop acoustic product. It's designed to be cooled in a data center environment. So when you class it compared to our desktops, it's a very noisy box in comparison to a ThinkStation tower. But yeah, they can be mounted anywhere, but they've been designed to operate within that data center server room environment.
And can Threadripper Pro be made into a rack mount?
Yes, so all the ThinkStation products are P520 and above and have been designed to be rack mounted. So we have a rack kit for the ThinkStation P620. And then you can rack mount that within the data center or within a normal sort of office environment because that has desktop acoustics and that's been designed for desktop environments. That's 4U in size, and that is something I know a large number of customers are currently testing for because 64 cores in a 4U low acoustic product like the ThinkStation P620 is very versatile when you look at sort of remote workstations and powerful workstations.
Got a question here from Rachel Berry. Hi, Rachel. In the engineering college scenario where students are in a classroom where COVID is trying to be reduced, what's the best way to allow multiple students access to workstations in a classroom if it's free versus a one user who owns a machine?
Okay, I think I'll get that. Yeah, so the previous way of working was, a classroom full of people all with their own workstation. And the complete opposite, as we're now experiencing, is that entire classroom full of people accessing those workstations remotely. On a one-to-one basis, those workstations can be mounted anywhere within the educational environment, anywhere within the college, and they can use the TGX software, which we have from Mechdyne Corporation, to have one-to-one access to that. But the workstations essentially are allocated to those users on almost a permanent one-to-one basis. So an alternative way of looking at that is to still leverage something like TGX, but use a connection broker where you could have a pool of workstations, say 30, and then users can connect to those based on the class role, the software they're using as and when they're free. And those workstations can be physical or virtual. So something like the P620 is a Swiss Army knife of products because it can be that single powerful workstation for one user, but it can be then turned into 64 much smaller workstations if you're doing basic 2D drafting work. But on top of the hardware stays the same, but on top of that, you would use TGX plus some sort of connection broker. Something like LeoStream is a great example there that can connect into the infrastructure and allow your students to access those workstations in whatever format they may need.
Okay, thank you. Going to Mr. Katz and Rob. In games, PCIe Gen 4 doesn't seem to make much difference to 3D performance. Why does it matter in the AEC application world?
Well, I would first off we hear a lot about the delay in opening large models. And so having PCI Gen 4 NVMe drives, the M.2 form factor, the first generation of PCI Gen 4 drives were incrementally better than the Gen 3 drives. The latest generation that have the newer controllers have far surpassed the Gen 3 drives. And so I think that for just sheer I/O, that is a clear benefit that's going to affect every user when they're working to open or if it's a locally stored model, right? And it's maybe less of an issue if it's going across a NAS, but for accessing local storage, the throughput numbers are I want to say, I don't know, 60 or 70% faster back and forth for local storage. So I think that's a killer. Yeah.
If you've got big files, that's the optimum.
Yeah. There is also a load of special use cases for graphics where you're doing multiple monitors and multiple graphics cards together, that the time it takes to talk to the bus is important. But again, software is going to take its time to develop. So it's been spending all this time finding ways to put things up to the graphics card and leave it there. Now they have a lot faster access. They can develop the software a different way. And again, the new APIs like Vulkan DX12 will exploit that more. And if in the game space, there's hardly anything DX12 that's true that's out there. So there's a few high-end games, but they don't use all of it. So you won't see that exploitation. It's like everything. There's always latency to develop new technology, but this is the new standard for a long time to come. So that's why PCI Express Gen 4 is important.
Okay. And are you working on optimizations with other multi-threaded AEC applications, specifically point cloud processing, simulation, wind? If so, can you tell us who?
We have conversations. Go ahead, Rob.
No, you start, Mike.
All right. Yeah. So we have active conversations with two very well-known point cloud companies, but and we've done some initial testing. The scalability looks great for the registration process, the most time-consuming process. But from our testing, we believe that we can do more. That there's more scaling to be gained. And so the NDAs are in place, the conversations are happening. Please stay tuned.
I think we're seeing.
Sorry.
I was going to say, I think we're seeing greater demand for many of these reality capture workflows. The data sets aren't getting any smaller. It's a reality for many of our customers on a daily basis in energy and construction to do site scans, and the processing, registration, and extraction of data is very, very processor intensive. We're seeing it happen in many cases on the edge, and I think the AMD technology and the PCI Gen 4 architecture is going to play a big role in the future to help accelerate those roles as these reality capture workflows become more and more common.
So with so many cores in Threadripper, how do you best manage multiple multi-threaded applications so they don't all fight for the same resources?
There's been a lot more updates in coding. So nowadays applications can actually look for unutilized cores and go, so they don't all use one core anymore. It's quite funny. If you actually put some application from 5 years ago on some of these big heavy systems, you start to see that they try to use one core, whereas most of the ISVs have updated their technology so they understand that can be run on 8 cores, 16 cores. So that doesn't happen so much.
Right.
So the other unique element of the Threadripper Pro architecture is the chiplet design, right? So a 64-core Threadripper Pro is actually 4 complexes, core complexes. Each is a 7-nanometer chip that has 16 cores, and through the programmatic interfaces, you can pin cores to specific, you can pin applications or pin processes to specific chip complexes and keep them separate in that way. That is a capability, and some software developers have started going down that route where if you just leave it up to Windows to decide where different threads are going to be run, those threads may float from chip complex to chip complex, and then you lose your cache and you have to rebuild your cache and you take a performance hit. So that's one of the techniques that help take further advantage of the Threadripper and Threadripper architecture, is to pin your application to a specific core or a chip complex. It's not up to Windows anymore to float around. And then you can balance out your workloads across the various cores available in the system.
Lenovo also has a performance meter that helps users decide which cores are used for which tasks. So with so many cores, you can cordon off certain sections of your workstation to do certain tasks.
So a couple of years ago, AMD seeded multi-core systems to Autodesk and Nemetschek, and they both did updates to their software, which is reflected now. So when Lenovo systems come out now, the software is ready for them.
So yeah, I think we were talking a few weeks ago, and you said that there are tools to help software developers to work out which bits of their code would make the most benefit to rewrite for I guess it's Threadripper, but for multi-core. Is that right?
Yeah, there's a lot more tools available today, so you can understand what bit of code can be used on multiple cores. And there's a lot of code. Some of the applications, some of their cores are 20 years old. You know what I mean? So it's some of that code is very, very old. But more modular style today is that you can actually update parts of that code. It's very, very hard to try and do all of it in one go. It's impossible. Millions and millions and millions of lines of code. So you update sections of it, and there's lots of tools out there now to analyze what your code is doing today and how you can find optimizations. And AMD helps with this. Mike works with a whole team of people that go out and say, look, let's have a look at your code and we'll help you, obviously under loads of NDAs. And that's why we talk about this NDA stuff, because we know we're working with software companies and they know we're optimizing it. But, it takes time. And the thing is, a lot of it's already happened. Autodesk and Nemetschek may change their software 2 years ago to make sure this was ready to use all these cores. That's why we seeded systems early. And now, with Lenovo having a workstation out there, an OEM workstation out there, makes a big difference.
So are there new compilers? Sorry.
I
was just wondering if are there new compilers available that are optimized for multi-threading?
Yeah, the compilers have supported multi-core, multi-threading for quite some time. I think what the bigger difference has been in the thread schedulers in the Windows operating system, and the thread scheduling has gotten more sophisticated in the Linux operating system as well. And with the advent of 64 cores in a single socket, that pushed the envelope in terms of the operating system capabilities and required infrastructure. And now it's a matter of applying the techniques, like I talked about with the thread pinning and what Chris was mentioning with respect to having the ability to cordon certain applications to different chip complexes within the die. So it's using advances that have taken place in the operating system. That's really what that's all about, Martin, right now. And the Intel compilers have been doing multi-threading for a long time. Threading building blocks is an Intel tool. All of those tools and developer tools and vTune for analyzing code performance, we use when we're engaging with software developers, we use our own tools like MicroProf and AMD's performance libraries, compute libraries. But we also use Intel's tools and help ISVs who are using Intel compilers and tools for diagnosing and troubleshooting and optimizing performance.
Okay.
But never forget that we don't always do one thing at a time. You know, I regularly use a 32-core system, and I have 20 or 30 windows open with different applications at the same time. It's great. I just flip between one to the other, 4K screens. You just get very used to that power. And I come back to use a laptop, you know, which has only got 4 cores, and I'm, why am I waiting? You know, you do get used to it, and it is great.
Yeah, desktops are still valuable. So just going to
desktops are selling very well at the moment. Desktop sales are up massively. People are working from home and they want power at home.
So go back to TAL. How scalable is Struct, and what is the largest structure you're working on?
Yeah, well, the question of scalability really depends, you know, on the type of use case. We're working right now on facades in you know, general sizes, and it's actually being used in different methods. So on one of the large ones, we're working on shading devices, which will be folded to shape. And then on another one, it'll be as a what's called a ventilated facade skin. So that's really, you know, a combination of the need. And of course, we're also developing modular elements, let's say for shading, like this pavilion that you saw. So the scalability really depends not only on size, but also on the scope. So if you're creating a modular element for shading and you multiply that by thousands, it really depends on how you look at it. But yeah, every time being called in for something different. So I think it varies on the project.
So I think when you look at your facades, I said they look complex and they look expensive. But I know you have a specific approach to removing the risk, because if you have a straight facade, a rectilinear building, okay, it seems like it's doable and there's low risk, everybody's been doing them. Your facades look incredibly complex. So how do you convince, or what do you offer as a service to your customers that de-risks that decision to have a complex facade?
Yeah, well, actually, that's a great question, also in line with our talks. So, you know, beginning as an architect, you're always confronted by these questions of who's going to manufacture it, what's going to happen. And one of the biggest limiting factors in design is mental risk. So when people see something that's, you know, a little bit going out of the box, they would limit the design stages because they don't want to enter later stages with unknowns. So one of the main ways of dealing with something like this that I've found is the best method for me is to do a reverse engineering and, you know, have relationships with a fabricator before you have the project. So that means we were talking about having adaptable systems. So if you take, you know, a single element and you're not dependent on a mold anymore, then you're no longer limited to, you know, doing exactly the same element, but you actually have variances. So yeah, just going the other way around, having a relationship with fabricators, with material companies. I've worked with Lucabond and 3A Composites, who are the actual manufacturers of the panels themselves. So, you know, always having the industrial knowledge about how things are manufactured, you know, until the level of the screw. And it's really a combination of two things. It's the materials and it's the fabrication. You know, I always have to play between these two. And then once you come and talk to a developer or to a, you know, a client and say, listen, the design you see here is already accounted for by a fabricator, and we can take care of the whole facade as a system. You're reducing that mental risk, and you're also providing a better product that was pre-engineered.
So do you work with the fabricators by sharing a Rhino model? Do you give them detailed drawings? Is it one-to-one? What's your communication methodology with digital fabricators?
So that, again, depends on the actual fabrication method. If we talk about, you know, folded structures, obviously we would be handing in a G code for 2D cutting. If we'd be talking about something like Woodstruct, where we have to kind of cut out different angles, we'd give a 3D representation of each and every wood log, or an Excel sheet that can, justify the different types of angles or the lengths. And I think what I try to do always is, learning the code of who is going to manufacture and talking in their language. And I can tell you that many times the fabricators themselves want to make the shop drawings. And you have to say, no, right? I want to make the shop drawings. You teach me how you think, because on the one hand, we have IP, which we don't want to share, and you don't want to hand out, your whole parametric system. And on the other hand, even if you did, and one thing that should be said is when you're doing parametric things, you have a lot of customized elements. So that means that you really have to control and know what the machine is doing, because you can solve something for one, right, for one element, but then when there's a change, that system is not going to work anymore. So really trying to get to the bottom of how the CNC machine works, or what you're going to work with. And some things I can, offer, and some things they'd have to do. I will not do, for instance, 3D printing code, right? I will design for a 3D printer, but I will not try to change go into the G code of a 3D printer. So it really depends on the type of material, but at least trying to go as deep as possible.
How easy is it for you to find fabricators that can have the same mindset in terms of their approach to fabrication?
And it's extremely hard, I have to say. If you look at these high-end models, right, from the top architects, you're going to find a very small group of fabricators. And that small group, is working on very high profit margins usually. So, when I work with fabricators, I try to find the mid-range, as we spoke before, and always trying to solve, something that is an in-between solution. And as you say, the mindset is the hardest thing. And that's why I always ask, what do you need from me? What is your MVP, right? That I can give you and you can just insert into your machine. I'll tell you exactly where you need to fold. So I find myself doing a lot of work with the engineering that usually an architect would not go into because he's not needed. But here, an extra factor is necessary. And that's why I say that the systems are built to be scalable, because it doesn't make sense to work so hard for one project.
That makes sense. I've got one more question, which is from Mike, Mr. Leach. So as we all started, we started on a journey with COVID. Let's end with a COVID-related question. So in your talk, you talked about full remote management. Can you give a bit more detail about how you'd manage a fleet of laptops used by staff working from home?
Okay, so every ThinkPad, mobile workstations or otherwise, the idea with an enterprise product is that they can be fully remote managed. So that would be from Microsoft Device Management Suite. You can run that from centralized tools within an IT environment, or elsewhere. Looking at some of the rack-mounted type workstations as well that also have those remote capabilities. I think with security now being key, it's not just managing the actual hardware itself, it's being able to locate it wherever it is in the world. Did you accidentally leave it in the back of a taxi cab? Was it, stolen or otherwise? So, security of those devices is something that can be managed at a hardware level using the Intel vPro or AMD remote management tools that are baked into the hardware itself. And then we have layered on top of that our Think Security platform as well, that allows you to then tile those together into your own chosen management tools. And there isn't just one, there's a number of ways that you can manage that hardware depending on what software licenses or management tools your organization may already use. But it's the key thing that segments a consumer product, a gaming laptop versus, a high performance workstation. On paper, some of those bullet points, processors, graphics, memory, all look exactly the same because at a hardware level, they can be very, very similar. But it's that enterprise layer on top that allows you then to have, a secure image, reliability, availability for a long time frame, and then those important management tools. We don't want to say that your IT team are monitoring every single move that you may do, but ultimately those tools can potentially give that power to IT individuals, so they can make sure that laptops are secure, that you're not saving things to the desktop, that you aren't then obviously then accidentally leaving them in places where they shouldn't be. So all of those are wrapped into those enterprise products. And from Lenovo, everything with a Think brand, ThinkStation, ThinkPad, they all have those enterprise tools built in.
But one of the questions popped up: why does the remote workstation need NVIDIA graphics?
Yeah, very good question. So our remote workstation solution, the hardware itself can drive, any mixture of, Intel CPUs with NVIDIA graphics, but the NVIDIA graphics are key for us. We've partnered with Mechdyne using their TGX remote workstation software, and that actually uses the NVIDIA GPU for doing things outside of just displaying graphics. So everything that's displayed on the screen, be it CAD applications, CAD data, email, games, videos, you name it, exists on the GPU itself. As if you plug a monitor in, it's powered from that GPU. But those pixels are held in the GPU frame buffer. And then the TGX software we run uses the NVIDIA encode and decode capabilities. So it takes those pixels from the NVIDIA frame buffer, it encrypts them, compresses them, it then sends them over the network, so they can be decompressed on a receiving unit at home or in a coffee shop or elsewhere. So these are parts of the NVIDIA GPU that aren't typically used for graphics. They're features of the GPU that they're not the major things you see on a spec sheet, but it's underlying architecture on that GPU that can do frame buffering, encryption, and both encode and decode.
Cool.
It's what makes the system so fast and such low latency, and why you do get that as local-like experience, because it's done on the actual graphics card itself rather than on the CPU.
Cool. So I'm out of questions. Thank you very much, guys. I think I'll wrap up our session today. I think we're going to about 50-odd minutes, 55 minutes of questions. That's great. And tomorrow we come back. We're in the day 6, no, day 5. I'm confused. So yeah, tomorrow we've got some interesting talks. We've got Andrew Rink from NVIDIA giving us his insight into Omnisphere, Omniverse. Ooh, that's all. Yeah. And we've also got Alex Coulomb, who's Agile Lens, and he's going to give a talk about working on a project and using VR at the start and then using VR at the end of it over a series of over a number of years. And you'll be able to see how the VR technology that's being used has changed and become absolutely amazing, from the rather blocky stuff of 5 years ago to the really interesting and photorealistic, super fast stuff that we're getting today. So tune back in tomorrow, 4 o'clock GMT, and we'll see you then. Cheers, everybody. Thanks.
Thank you.
Thanks,
Thank
everybody.
you. Bye-bye.
Bye.